Okay, for this explainer, we are heading way up north to Alaska. You know, the place we all picture as this vast land of ice and snow? But something really strange is going on. Alaska is seeing record-breaking wildfires at the same time its sea ice is rapidly melting. So, fire and ice happening at once? It's a real head-scratcher. Let's dive in.
Yeah, it sounds totally backward, doesn't it? How can a place that's famous for its gigantic glaciers and polar bears also be battling massive wildfires? You hear one report about fires raging, and then the next is about the sea ice just vanishing. So seriously, how can both of these things be happening in the exact same state?
To really get to the bottom of this, we need to look at it like a detective story. We've got two very different accounts coming from two different parts of Alaska. One is a modern news headline from the south, and the other is an oral history from a community way, way up in the far north.
So let's lay them out side by side. On the left, Claim 1, a news headline telling us Alaska is having bad wildfires because it's so dry and hot. Okay, but then on the right, a completely different story. Claim 2, an oral account saying the amount of old, thick sea ice is shrinking. Fire and melting ice. They really do seem like total opposites, right? Let's investigate.
Now that second claim, it comes from an incredibly important source of knowledge, the Inupiaq people. They've lived in the Arctic for thousands of years, and their oral histories are this priceless record of what the environment is supposed to look like. One Inupiaq whaler, Gordon Brower, has noted that the really old, thick ice, the stuff that survives for multiple years, is disappearing. This isn't just something they've noticed recently, it's a change they've seen happening over generations. So here we are. We've got two very credible stories about two very different things: intense wildfires on the land and disappearing ancient ice in the sea. The big question is, are these things actually connected? Or is it just a weird coincidence? Well, to figure that out, we've got to follow the data. All right, let's start digging into the evidence. First up, those wildfires. Is it really true that they're becoming a bigger problem in Alaska? What do the numbers actually tell us? And well, the data couldn't be clearer. You look at the trend over the last few decades, and you see that both the number of wildfires and how bad they are have been climbing. So, yep, claim number 1, that Alaska is having bad wildfires, definitely checks out.
And this map gives us a perfect picture of why this is happening. It's from NOAA, the National Oceanic and Atmospheric Administration, and it shows that back in the summer of 2019, huge chunks of the state were way warmer and drier than usual. All those brownish areas, those are the exact conditions you need to fuel massive wildfires. So that hot and dry headline was spot on.
Okay, so what about that second claim, the sea ice? Well, the data shows the exact same thing Gordon Brower was talking about. There's a clear downward trend, not just in how much sea ice there is overall, but specifically in that older, multi-year ice. The science fully backs up the Inupiaq oral history. The old ice is definitely disappearing.
Okay, let's just recap for a second. We've confirmed both sides of the story. The wildfires, they're real, and they're getting worse. The disappearing sea ice, that's happening too. The data supports both. Which brings us right back to our central mystery. What's the link? How on earth are these two things connected?
This is the moment. This is where the two separate trails we've been following finally meet. It turns out there isn't some complex, tangled web of causes. There is one single thing, a common cause, that's driving both of these massive changes.
And there it is, the single connecting piece. The culprit behind both the out-of-control fires and the melting ice is rising temperatures. Just that one thing. This single change is what's affecting both the land and the sea in such dramatic ways.
And this chart, this is really the smoking gun. The data shows a steady, undeniable, long-term increase in the average temperature across Alaska. We're not talking about a random heat wave one summer. This is a consistent upward trend, year after year. And this is so important. This seemingly small change in the average temperature is what sets off two very different and very large chain reactions.
So let's break down how this works. First, the wildfires. It's actually a pretty straightforward chain reaction. The rising average temperatures mean the snow melts earlier in the spring and the summers get longer and hotter. All of that leads to drier forests and tundra, which, you guessed it, massively increases the risk of wildfires. And now for the ice. You've got the exact same starting point, rising temperatures, but it sets off a totally different chain reaction. Those warmer temperatures heat up both the air and the ocean water itself.
Warmer air and warmer water, well, they melt sea ice faster, and they make it harder for new ice to form and stick around long enough to get old and thick. Same cause, completely different outcome.
So what does all this mean? What's the big lesson here? Well, it turns out the Alaskan paradox isn't a paradox at all. It's just a powerful, real-world example of how our planet works as one big, interconnected system.
And this is really the key idea to take away from all this. A seemingly small change in one piece of the puzzle, in this case the average air temperature, can set off these huge, and sometimes really surprising, chain reactions somewhere else. A change in the atmosphere is directly connected to big changes in Earth's water system, whether that water is supposed to be in the soil of a forest or frozen solid in the ocean.
And this whole long-term trend, well, it has a name you've probably heard: climate change. It's not just about one weirdly hot summer or one bad fire season. It's defined as a change in the average conditions, like temperature or rainfall, in a specific place over a really long time. And as we've just seen, that's exactly what the data is showing us for Alaska. And that leaves us with a huge question to think about. If this one change, rising average temperatures, can connect wildfires on land with melting ice at sea in Alaska, it really makes you wonder what other seemingly separate events happening all around the globe are actually connected by the very same thing: